Hello! In this video, we are going to prove the following theorem. Suppose a1, a2, an, and so on and so forth is a strictly increasing sequence of positive integers. Then an is greater than or equal to n for all positive integers n. Now, because this is a strictly increasing sequence, what that means is that an plus 1 is greater than an for all positive integers n. And since our sequence is a sequence of positive integers, this means that every term in the sequence is a positive integer. Okay, now our goal is to prove that an is greater than or equal to n for all positive integers n. Well, since we're trying to prove a statement about all positive integers, let's use induction. So let's start with the base case. In the base case, we're trying to show that this is true in the case where n is equal to 1. Really, we're trying to show that a1 is greater than or equal to 1. Well, to start, since every term in our sequence is a positive integer, we have that a1 is a positive integer. And since a1 is a positive integer, well, we know that every positive integer is greater than or equal to 1. So a1 is greater than or equal to 1. So we have shown that a1 is greater than or equal to 1, which means we have shown that this is true in the case where n is equal to 1. So this completes the base case. Now let's move on to the induction step. In the induction step, we give ourselves an arbitrary positive integer where this is true. The whole goal of the induction step now is to show that this is also true for n plus 1. That is, we want to show that an plus 1 is greater than or equal to n plus 1. Well, since we know that this statement is true, well, that means we know that this is true for every positive integer. Well, since it works for every positive integer, it must work for the positive integer n that we have here. So taking n to be the n we have here, we have that this is true. So an plus 1 is greater than an, and also an is greater than or equal to n. These two inequalities tell us that we must have that an plus 1 is greater than n. But then, since an plus 1 and n are integers, this is equivalent to saying that an plus 1 is greater than or equal to n plus 1. Right? These two inequalities are equivalent to each other. If you recall, the following statement is true. Given any two integers a and b, a is greater than b if and only if a is greater than or equal to b plus 1. We're basically just applying this fact to say that this inequality is equivalent to this inequality. So, yeah, this is true. So putting this together now, we see that we have shown that this is true where instead of n, we have n plus 1. And that was the whole goal of the induction step, so this completes the induction step. Because we've completed both the base case and the induction step, this closes the induction. And so, by mathematical induction, we have shown that this is true for all positive integers. So we've proven the theorem, which means this completes the proof. And so yeah, that's pretty much it for this video.